Okay, so let's get into a discussion of saturated, unsaturated, and supersaturated solutions. Now, what these terms are referring to are basically, well, it's related to the solubility of a solute in a solvent. So, firstly, let's start off with this statement right here, which says that at a specific temperature, there's a limit to the amount of solute that will dissolve in a given amount of solvent. And that is basically what we mean by the solubility of a solute in a solvent. It is basically the maximum amount of the solute that will dissolve in a fixed amount of solvent. Now, when we have this situation, the solution is said to be saturated. So a saturated solution is one where you have the maximum amount of solute in a fixed amount of solvent and it's dissolved, all right? So we call that a saturated solution, as I said before. And what you'll find if you look at things at the microscopic level is that in a saturated solution, you have two processes that are occurring simultaneously. One is where you have the solute that is basically forming a solid out of the solution. So it's crystallizing out of the solution. So we call that crystallization. And then you have another opposing process where the solid is dissolving into the solution. So basically, you have a back and forth taking place between the solute that is dissolved and the solute that is undissolved, right? So you have one process taking place going in one direction, represented here. The other process is going in the opposite direction. And you have this back and forth. The rate of the forward process is equal to the rate of the reverse process. So you have a state of dynamic equilibrium taking place. So if you look at the diagram here below, you'll see it demonstrated here. So basically, as I said before, you have the solute that is coming out of solution to form a solid. So that is represented by this sphere coming out of solution and ending up with the solid. And then you have another solute leaving the solid and going into solution. So that's basically what's happening in this situation where the solution is saturated and you have undissolved solid present in the mixture. You have the back and forth taking place between the undissolved solute and the dissolved solute. So what we're going to look at here is basically how a saturated solution is formed. It's very simple actually. So let's say you have 100 grams of water at 20 degrees Celsius and you decide to add 5 grams of potassium chloride to that water. Well, the 5 grams of potassium chloride will easily dissolve, right? So you'll see no particles of the solid when it's added to the 100 grams of water at 20 degrees. If you decide to add 5 more to get 10 grams, again, it will dissolve, no problem, all right? Then if you add another 5 grams to get 15 grams total, then again, the solid will dissolve. And if you continue that to 20 grams, again, solute will dissolve, solution will be unsaturated, and then if you increase it to 25, it will still dissolve, all right, nothing will happen, excepting that the solid will dissolve. And when you go to 30 grams, same thing is going to happen, all right, and then if you go to 34 grams, then what will happen is it will dissolve, and that's the upper limit, because if you decide to add any more solute, potassium chloride, to the water, it will not dissolve. So at this point, the solution is saturated, all right? So if you add 1 more gram, no more potassium chloride will dissolve. And that's because the solution has the maximum amount of solute that will be accommodated for 100 grams of the solvent, all right? So that's what happens at 20 degrees, okay? And the solution will be saturated at that point. Now, let's consider, oh, by the way, statement here is very important. A saturated solution may be either dilute or concentrated, depending on the solubility of the solute. So, in the case of potassium chloride, that would be 34 grams. But it is possible for another solute to have a lower solubility, much lower or even much higher, right? So, it all depends on the solute-solvent combination. Now, what if you decide to change the temperature? Well, as we said before, the temperature will have an effect on the solubility of solid compounds in water. Usually it increases, and we're going to see that demonstrated here. So let's say we decide to increase the temperature from 20 degrees to 50 degrees. All right? So the undissolved potassium chloride, because remember the solution, it was unsaturated at 20 degrees. When you raise the temperature to 50 degrees, what happens is that the solute that is undissolved will go into solution, and now the solution will be unsaturated. All right? So basically, what we can conclude is that a solution that is saturated at one temperature may not be saturated at another temperature. All right? So the saturation level is basically based on the temperature, in addition to being a function of the nature of the solute and solvent. Okay, so again, a saturated solution may be either dilute or concentrated, even at lower or higher temperatures. All right. Now, what happens if we suddenly take the solution at 50 degrees and decide to cool it to 20 degrees Celsius? All right. So if we do that, what's going to happen is that no solid will precipitate. Now, this might sound counterintuitive, especially since the solubility of potassium chloride at 20 degrees is 34 grams per 100 grams of water. But if there are no potassium chloride precipitating, what that means is that the solution contains 1 gram of potassium chloride in excess of the saturation limit. All right? Now, that is a highly unstable situation. In fact, we call this type of solution a supersaturated solution, right? So a supersaturated solution is one that contains a solute in excess of the solubility limit of the solution, right? As I said before, that's a very unstable situation. If you do anything to that solution in terms of disturbing it, then all of a sudden you're going to have a precipitate forming out of solution. So typically what is done, for example, in some cases, and you're going to find this to be true in organic chemistry, if you plan to do organic chemistry, you can scratch the walls of the container with a glass rod, which produces very microscopic particles of glass. And basically, once the glass enters the mix, it forms a surface which allows for the spontaneous formation of precipitates. All right. Even shaking the vessel can do that as well. So a supersaturated solution is very unstable, and therefore anything that happens to it in terms of being disturbed would cause precipitates to fall out of solution. Okay, we're going to stop our discussion here, and the next topic we're going to talk about is the type of reaction that takes place in an aqueous solution. Okay, until next time.